Hi guys, in this very class, we're going to be looking at the solution for the first set of questions we're given as a take home in our previous lesson on addition and subtraction of basic operations on modular arithmetic. If you're just seeing those very questions for the very first time and you want to give it a try, I would advise you to pause this very video and give it a try. So let's dive right into it. We are asked to solve these two major questions on modular arithmetic. The first is 5 plus 7 to be solved in modulo 8. And the next is that's 1b, 5 minus 7 to be solved in modulo 8 also. So we're going to be solving this first set of questions. We are given two major sets, the 1a, the 1b, then the 2a and the 2b. So let's quickly solve the very first one. The first one, 5 plus 7 to be written in modulo 8. How do we do that? We could use a direct approach, or we could use our table to create an operation table, under this. So 5 plus 7 will give us 12. So how do we write 12 in modulo 8? How do we do that? 12 to be written in modulo 8, that will give us, don't forget, this 12, you're going to divide this 12 into 8 places. So what do we do? That will be 12 divided by 8, which will give us 1 remainder 4. So don't forget, we have just 1, 8, and 12, so 1 remainder 4. So that will give us 4 modulo 8. As simple as that. Very easy. I'm very sure that many of us got this right. So 5 plus 7 is 12. So 12 modulo 8 is 4 modulo 8. So the same thing applies, for this. 5 minus 7 to be written in modulo 8. So you could use a direct approach. After direct approach, then we're going to look at how we could quickly use the table, the operation table, to solve this. So 5 minus 7 will give us 5 minus 7 will give us minus 2. So how do we write minus 2 in modulo 8? How do we do it? Now don't forget, this is a negative result, unlike this, that is a positive result. So how do we do this? How do we write this in negative stuff in modulo 8? We've done this in our previous set of classes. If you have not seen those classes, I would advise you to go ahead and do that. So minus 2 will be divided by 8. Minus 2 divided by 8. How do we do that? I'm going to create our 8 times table. Then we look for minus 2. But this time around is going to be negative set of digits. 8 minus 8 times 0 is 0. 8 times minus 1, it gives us minus 8. Now we are looking for minus 2. So don't forget, whenever we are dividing, we either look for the very stuff that's the numerator or the dividend. So if we don't get this very dividend or numerator, we have to get something very proximate, something very close to it. So minus 2, this 0 is bigger than minus 2, don't forget. While minus 8 is smaller than minus 2 and is the closest to it. And another thing is farther away from it. So we're going to go with this. 8 and minus 2 is minus 1. Remainder, minus 2 minus 8 to give us minus 6. So what's that going to be then? That will give us 6 modulo 8. As simple as that. We said it also in our previous set of lessons that whenever we are asked to convert negative result to any given modulo, all we can do is that we can assume the positive result, and after converting it, and we know what we're going to do from there. So let's quickly look at that. Minus 2 to be written in modulo 8. If you don't want to solve it this way, using this table, then we can assume that this is plus 2 to be written in modulo 8. So how do we write plus 2 in modulo 8? Don't forget, plus 2 in modulo 8 will give us C2 modulo 8. So if plus 2 is 2 modulo 8, then minus 2 to be written in modulo 8 will give us what? 8 minus 2 will give us what? 6 modulo 8. As simple as that. So this is how to solve these two major take-homes. Very simple. Right? This is how to use the direct approach. So right away, we're going to be using the operation table under addition first and then under subtraction. So quickly, let's create a table to get this done. So don't forget, we are talking about addition here. So how do we do that? Modulo 8, we're going to have numbers ranging between 0 to 7. So from 0 to 7, these are the set of digits you're going to be using. So we have 0, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, and we have the very last digit 7. So the same thing for those very axes. We have 1, we have 0, beg your pardon. We have 1, we have 2, we have them just like this. Then we have 3, we have 4, we have 5, we have 5, and after that we have the 6, and the very last we have the 7. To the very last one, we have the 7. So you have the 7. So these are the set of figures you're going to be working with. All this make up the modulo 8. So 0 to 7, 0 to 7. So you're going to be adding them together. So 0 plus 0 will give us 0. Quickly, don't forget what we're solving right here is 5 plus 7. So let's see if you're going to get the same result. 5 plus 7 is 4 modulo 8, as you can see right here. 5 minus 7 is 6 modulo 8. So we're using this operation table first under addition. So let's see if you're going to get the same result. 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2, 0 plus 3 is 3, 0 plus 4 is 4, 0 plus 5 is 5, 0 plus 6, 6, 0 plus 7 is 7. So don't forget, we're talking about modulo 8. All the set of results, none of them is up to the modulo 8. Whichever one is up to modulo 8, you're going to reduce it to something smaller than modulo 8. Since you're talking about modulo 8, we should not be having results up to modulo 8. So next, 1 plus 0 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5, 1 plus 5 is 6, 1 plus 6 is 7, and 1 plus 7 is 8. Now you can write 8 here because you're talking about modulo 8. So 8 and 8 is 1, remainder 0. So you're going to write 0 down. Once you get to the maximum, which is the modulo, these are standard, it's going to wrap around. It's all about writing the 8. We start all over again from 0. So next, 2 plus 0 is 2, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 2 is 4, 2 plus 3 is 5, 2 plus 4, 6, 2 plus 5, 7, 2 plus 6, 8. All the way right there, we write 0. 2 plus 7 is 9, we write 1. So same thing, yeah, 3 plus 1, 4, plus 2, 5, 6, 3 plus 4, 7, 3 plus 5 is 8, we write 0. 3 plus 6, 9, we write 1, then here we write 2. 4 plus 0 is 4, 4 plus 1, 5, 4 plus 2, 6, 4 plus 3, 7, 4 plus 4, 8, write 0. Then write 1 here, 10, write 2, 4 plus 7, 11, we write 3. As simple as that. So you have about 3 more to go. 5 plus 0 is 5, 5 plus 1 is 6, 5 plus 2, 7, 5 plus 3, 8, we write 0. 5 plus 4 is 9, 8 and 9 is 1, remainder 1, we write our 1. 5 plus 5, 10, 8 and 10, 1, remainder 2, write our 2. 5 plus 6, 11, 8 and 11, 1, remainder 3, write our 3. 5 plus 7, 12, 8 and 12, we give us 1, remainder 4. So we're done with that. So the next 6, 6 plus 0 is 6, 6 plus 1 is 7, 6 plus 2 is 8, we write our 0. Then 6 plus 3 is 9, we write 1, 2, 3, 4, and 5. As simple as that. 6 plus 7 is 13. 8 and 13 is 1, remainder 5. So write the remainder down. So the very last set is 7 plus 0, which is 7. 7 plus 1 is 8. We write 0. Don't forget. Here, 1, 2, 3, 4, 5, and 6. So this is an operation table for this. So let's quickly see if we're going to get the same result. 5 plus 7. 5 plus 7. 5 plus 7. This is what we're talking about. 5 here plus 7 here. 5 plus 7. What are we going to get there? 5 plus 7 will give us 4. Don't forget the 5, then the 7, which is 4 modulo 8. As simple as that. Okay, guys, let's create a subtraction operation table to get this solved. That's the second question. 5 minus 7 to be written in modulo 8. We're going to be using the table similar to the very first table. So you're just going to be creating something similar. So right here we have the subtraction this time around. We'll write out the set of digits that make up the modulo 8. 0 to 7, don't forget it. 0, 1, 2, 3, 4, 5, and 6, just like base 5, just like base 7. Very much like number base. So right here we have the same set of numbers. 0, 1, 2, 3, 4, 5, 6, and 7. Just like this, let's get our result. So quickly, let's see if you're going to get the same results. If you're going to get the same result with a direct approach. So right away, don't forget this is subtraction. When it comes to subtraction, nothing is commutative here. You can't go, when you go like this, it's not the same as going like this. So you're just going to be going like this from here to here. So this 0 minus 0 will give us 0. Then 0 minus 1 will give us minus 1. So if you're going to write minus 1 in modulo 8, we're going to assume that the minus 1 is a positive 1. So minus 1 to be written in modulo 8, we assume that it is plus 1. So right plus 1 modulo 8, that'll also be 1 modulo 8. So you take the 1 away from the 8, that'll be 7 modulo 8. So it's going to be something opposite. When it comes to this, don't forget, just like the example we looked at, this first set of results are constant. Then all these other ones, they'll be written from the end, from the other end, when you compare it, with the addition table. So 0 minus 0 is 0, 0 minus 1 is minus 1 to be written with the 8, that will be 7. Don't forget that. So 0 minus 2 is minus 2, minus 2 written with the 8, that will give us, 6. 0 minus 3 minus 3 to be written with the 8, that will give us, 5. 0 minus 4 minus 4 to be written in modulo 8, that will give us, step 4. Nothing changes there. So 0 minus 5 is minus 5. Ordinary 5, that's plus 5 in modulo 8, is 0 minus 5, that's 5 modulo 8. So that will give us 3. So 0 minus 6, so that's going to be 2. Y 0 minus 7 is minus 7. Ordinary 7 in modulo 8 is 7 modulo 8 also, nothing changes. So subtract, now give us 1. So this is exactly like what we got when we're working on addition table. The addition table is just the differences here for the addition table is 0. The 1 here, it kind of change the position, or swap their position. So 0, 1, 1, 2, 3, 4, 5, 6, and down like that. This is constant. So we're doing the same thing. So 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 2 is minus 1 to be written in modulo 8. That will give us, minus 1 to be written in modulo 8. Ordinary 1 is 1 modulo 8, so that will give us 7. 1 minus 3 is minus 2 to be written in modulo 8. That will give us 6. 1 minus 4 is minus 3 to be written in modulo 8. That will give us 5. 1 minus 5 is minus 4 to be written in modulo 8. That will give us 4 modulo 8. Nothing changes. So 1 minus 6 to be written in modulo 8, that's minus 5. 1 minus 6 minus 5 to be written in modulo 8. That will give us 3 modulo 8. Why 1 minus 7 is 1 minus 7 is minus 6 to be written in modulo 8. That will give us 2. So next 2 minus 0 is 2. 2 minus 1 is 1. 2 minus 2 is 0. 2 minus 3 minus 1, that will give us 7. 2 minus 4 is minus 2, that will give us 6. 2 minus 5 is minus 3, that will give us 5. 2 minus 6 is minus 4, that will give us 4. And 2 minus 7 is minus 5, that will give us 3. So 2, 1, 0, 7, 6, 5. So 3 minus 0, next 3. 3 minus 1 is 2. 3 minus 2 is 1. 3 minus 3 gives us 0. 3 minus 4 is minus 1. And we're going to write that in modulo 8, that will give us 7. 3 minus 5 minus 2, that will give us 6. 3 minus 6 minus 3, that will give us 5. 3 minus 7 minus 4, that will give us 4. So you have 4, 3, 2, 1, 0. 4 minus 1 is minus 1, right at 7. Then that will give us 6 minus 2. 4 minus 0 minus 3, that will give us 5. So yeah, 5 minus 0 is 5. 5 minus 1 is 4. 5 minus 2 is 3. 5 minus 3 is 2. 5 minus 4 is 1. 5 minus 5 is 0. 5 minus 6 is minus 1 to be written in modulo 8. That will give us 7. 5 minus 7 is minus 2 to be written in modulo 8. That will give us 6. So we have a penultimate number. So 6 minus 0 is 6. 6 minus 1 is 5. 6 minus 2 is 4. 6 minus 3 is 3. 6 minus 4 is 2. 6 minus 5 is 1. 6 minus 6 is 0. 6 minus 7 is minus 1. Modulo 8 is 7. So next, 7 minus this is 7. 7 minus 6 is 1. 7 minus 2 is 5. 7 minus 3 is 4. 7 minus 4 is 3. 7 minus 5 is 2. 7 minus 6 is 1. 7 minus 7 is 0. The table is ready. So this is the table. So let's see if you're going to get the same result. 5 minus 7 to be written in modulo 8. 5 minus 7, let's see it. 5 minus 7. So 5 minus 7. So you're going to get the same result. 5 minus 7. That gives us 6. Exactly. No doubt. So 5 minus 7 to be written modulo 8 is 6 modulo 8. So I'm very sure that majority of us got this very question right. I'm very sure of that. You see how easy it is. So we've come to the end of this very lesson. If you gain one or two things from this very lesson, I'd love you to subscribe to the very channel at Edge Mosaic and give me a follow at Revelation on Facebook. And please share this lesson also with others. See you in the next lesson. Thanks and bye for now.